So far, we have built up a thought process wherein we have learned the various aspects of human behavior and discussed expert systems, knowledge, reasoning, and so forth, and learning. This topic, this video is about how to, how to make machines. How do they learn? So, what is machine learning? I typically like to use the word ML, just short form for machine learning. The goal of machine learning is to build a computer system or computer systems that can learn from their experience and adapt to their environments. Adaptation, right? Adaptation means to adjust yourself. So what does adjustment mean? Adjustment means, or adaptation means, that you are going through an experience and you learn and understand what's happening around you, and you adjust yourself, okay, to that changing environment. And not only that, machine learning also means that an increase in its knowledge. So this adaptation is actually linked to the knowledge, so that the next time the same thing happens, the system can show improved behavior, performance. And incidentally, this is one of the limitations that we identified when we were discussing expert systems. They don't have an explicit or implicit built-in learning capability. So obviously, learning is an important aspect or component of intelligence. And then there are both theoretical and practical reasons to support such a claim. Some people might think that intelligence is nothing but the ability to learn, okay? Though another set of people thinks that intelligence, an intelligent system, has a separate learning mechanism, some box somewhere, which helps improve the performance of other mechanisms of the system. However, learning, we all understand and agree, I'm sure you will, that making machines learn is also equally good, and learning is important. Now, human learning is a process, as I said, of acquiring and updating knowledge. So you keep on getting new information, knowledge, and update yourself. And this is what the child does. Now, our behavior, skills, values, and other ethics are required to process information through our minds and learn. Human learning occurs as part of various aspects, as part of education, personal development, or other forms of formal, informal trainings, learning from the environment, as I said before. For instance, as I said, the child learns from the environment the concept of hot, cold, love and affection. So the child can really quickly understand, when you're very, you like him, like her, and you treat them accordingly. So she picks up love and affection. Now, both humans as well as machine learning generate knowledge, okay, one residing in the brain and the other in the machine. But is this really the only difference between the two? So some characteristics of or features of machine learning, like image or object recognition, speech recognition, or language comprehension, what is being said, okay? Instead of remembering everything, can you comprehend what I'm telling you? So that's like comprehension. Typically, automated report writing, etc., are based on machine learning, ML, okay? And there's a potential of combining human and machine learning. For instance, in healthcare systems, where analysis of symptoms of the illnesses are performed with a machine learning system that crunches through massive parallel medical records and then determines the probability about the most likely cause of the problem, okay? And one of the reasons, in fact, a major reason that machine learning has become rapidly growing interest in all across the globe is because it helps improve the system itself, and it's a major subset of AI research. The application of so-called neural networks, NNs, they mimic functioning of the human brain, coupled with the ability of low-cost, massive computational hardware resources. Without enough hardware resources, probably this would not have happened so quickly. And this provides opportunities to solve problems for which so far humans, well, we have relied on human brain power. So we're trying to challenge that power. Huge data of pools, big data, very common word, consisting of medical and financial information, picture libraries, information about consumer behavior, to name just a few, are processed with various types of highly complex algorithms to produce digital knowledge without typical conventional programming. Various aspects, apps such as image object recognition, you're given various images and you recognize, whether it's a tree or it's a train, street light. Have you used something called CAPTCHA? That's what it is. It brings something in front of you and asks you, can you identify, the objects in there? And that is what recognition is about. So this is dependent. They're trying to differentiate whether somebody who's trying to log in is a machine or a human being. So object recognition, speech recognition, language comprehension, as just said. And the list is growing. Now these apps can also be combined with conventional systems and realized in, for instance, self-driving cars or management of other robotic devices. As I said about healthcare systems. So the machine learning, the capabilities, hugely powerful hardware working behind that. Now you can have the system support you, and whether you use the recommendation of the machine learning or not, in the case of, let's say, medical systems, you may or may not choose to accept the advice given by the machine learning system. And there are interactive brain training, games, so that you can actually improve your working and your behavior, your eye contact, and learning several things. And so sports activities, sleep, healthy diets, and so forth. So this is just about the tip of the iceberg in terms of, machine learning. I hope you've enjoyed it. We'll see you next time. Thank you very much.